Hi, everybody. Very excited to be here. The last time I attended a conference in person was in 2019 in OpenStreetMap Minneapolis. So that time I flew all the way from Israel. So this time it was only like 6 hours from Santa Barbara, where I'm doing my postdoc in SPARA and the Geography department, UC Santa Barbara. And today I'm going to speak about simplifying OpenStreetMap data, reducing multi-lane street to single lane. So what motivated me to address this challenge. So in SPARA, we are interested in any practical, conceptual ideas that can promote active transportation, like walking or biking, so on. For example, you can see these two amazing projects, which is crowdsourcing map that people all over the globe can share their personal experience about collision or near miss or death of bikes or any walking issue, walkability issues on the street using walk maps. And one of our project is in collaboration with researchers from Israel and from Italy. And in that project, we try to generate the neighborhood walkability indices by street level assessment. So for this project, we need a reliable yet simple state network. Just remember, our focus on walking, not on cars. So in Tel Aviv, it was quite simple to generate this simple network, because there is an open source of the Tel Aviv municipality with a lot of GIS data that everyone can access the data. But in Torino it was quite difficult, we didn't have this kind of open source, so we decided to go to OpenStreetMap. Now, OpenStreetMap is amazing, of course, and in OpenStreetMap, the goal, as I understand it, is to reflect the actual reality as much as it possible. Sometimes, for example, in our case, it's too details. So we need something more simple. We need every part in the street will be presented by one lane or just one segment, not many. So I'm going to show you how we reduce the number of multi-lane street into one single lane while maintaining the topology between the street or the connection between the street networks. So for this example, I'm working with case study of Torino, and specifically about this area in this on OpenStreetMap, and then after we're using OSMNX package, which is amazing package to everyone that works with Python with OpenStreetMap. And we try to, and with this example, I will show you how we simplified the streets. So the model or the algorithm consists of 4 main components. The first one is some preliminary task, which is remove street or remove segments without name and tunnels. In addition, we also remove roundabouts, but we have to address roundabout later because we need a roundabout, but instead of lines or instead of segments, we need it as a point. And also we calculate for each street, for each segment is bearing or azimuth. So here's the result after the first step. First task. So a lot of work should be done here. But also, it's only the first task. The second component is identify multi-lane streets. So we all of the streets was grouped by their name, and after that we use DBScan to classify each group of segments that belong to the same street into classes based on their azimuth. For example, this street we have all three classes. The -1 class is actually not class, but outlier. And then for each class, which is just out of the three segments, we translate the street to the right or to the left with and create buffer around the street. If the buffer is overlap other street, so that means we have here case of multi-lane. So now when we know that for each street we have multi-lane street, so we need to fix we need to convert it into one lane street. And that's lead us to the component number. So I think I'm not going to talk bigly about each step here, but the idea is to take a group of lines and convert them and make them polygons, and then simplify this polygon. So now we can find the farthest points on this polygon and create new line. This new line is could be the new line, or we can add more vertices to the lines based on the distance between the new line to the original points. I wish I have more time to add figures to this slide. I think it would be much easier to understand. But let's leave it that way and continue the result we have. So this is the case for the last slide, and then the result after. So instead of multi-lane, we have single lane, but we still have many problems. These are the right top is the roundabouts, the missing roundabouts. We need to fix. We have every line could be intersected by each intersection. This line is not, it's ended in 14. So, and that's so on. So that leads us to the last component, which is fix or update the node. So we started by updating the topology, and then the roundabout was become points, and I'm not going to say now exactly how we did it, and then extending the line and so on. So this one, I mean, it's thanks. So well, let's just look on the last result I have. Again, this one, the data we put out from OpenStreetMap without doing any process. And here we can see the result after all in the process I just trying to describe. It's not perfect, but it's much better than the beginning. And on this state networks, absolutely can start and to calculate walkability index. Other view on the results from all when looking on entire Torino. The red line is the original data set. The green one is after the processing. I also tried that on Victoria, Canada, because we are working a lot with the data from Victoria. So there, for example, here we can see a lot of red line, but they have also the same street name. So that's the reason they were deleted. And I try also on Richmond, and many streets here was removed because with no name, service name or service road, or just the parking. And in the middle of the main road, we see it's bad. We understand why. So as I said before, it's not perfect, but it's much more. And that's the link to the code project. Right now, it's just code, and hope that the next 2 weeks or 3 weeks, everyone can use it. And so I need add some documentation and so on. And that's it for me.